Hey, first of all, thanks a lot for coming. Really appreciate it. Glad we could pack everybody in here. My name is Dan Winters. I head up business development for Amazon Game Services. And again, really happy that you guys could make it, and we're thrilled to be able to tell you more about what we're doing. I hope that you come away with two images from what we're going to share with you today. One is that we are 100% committed to you guys, the customers. Very important for us. Every single day we stew, obsess, think about ways to help your jobs be more easy and for you to make better games, first and foremost. The second part is that we're really focusing on building community-driven games. And I'll tell you what that means in a little bit, but it is basically end-to-end solutions for game developers, so that we're there at the very beginning of your pre-production phase all the way to the very end when you're trying to help your game succeed in the market. Before I get going, I'll introduce myself a little bit, but I want to ask you guys, who in here are game developers? All right, way to go. How many are technical game developers versus designers, producers, stuff like that? So we got some creative folks in here, right, on both technical and on the design side? Awesome. So this will appeal to all you guys, and then later on, we have a technical evangelist named Kevin Ashman who's going to share with you a little bit more detail on the technical side. So a little bit about myself. I've been in the business for about 25 years. I was telling Aiden, correct? Aiden, sorry, pronunciation. I was telling Aiden that I've been around for 25 years, kind of got in by accident, but have been with a number of different companies, Activision and Disney and Electronic Arts, and have been a game player, been a game maker, been a game publisher, been on the business development side, so I've kind of run the gamut in the game business. I think at some time they're going to kick me out of here pretty quickly. So I've seen the business from a lot of different perspectives. And I've been around for a long time, and I've seen a lot of changes over the course of the time that I've been around. Primarily, when I first started playing games and making games, we used to go to the arcades. And the one thing that hasn't changed is that we as game players and game makers are fully committed to getting to our games. We find a way. In the old arcades, we had Mom drive us to the bowling alley to go play Missile Command or Donkey Kong, whatever we were going to play in those days, right? But we found a way. And that was kind of community-driven, but it was still an isolated experience that we ventured into and found a way to get to our games. And then eventually, games got to come to our home. We stayed committed, right? This guy's pretty committed. This is like me playing Resident Evil or Final Fantasy in my basement with pizza boxes and soda cans all around till 4 o'clock in the morning, and we stayed committed. And then obviously games became more multiplayer. We started having LAN parties, and we stayed committed. In fact, I don't know if you can see this or not, but look at this dude. This guy has taped himself to the ceiling, right? This is freaking committed, this guy. Taped himself to the ceiling. Why has he done that? Because he believes that the blood flowing to his fingers is better so he can respond quicker in a LAN party. Smart dude, right? And very committed, right? So, and then through our LAN experiences and multiplayer experiences, we started generating these large communities. People that we played both locally and around the world, either with or against people. And we started connecting with people all over the world. And so the model of how we interacted with our games started to change just a little bit, right? Communities became a much bigger part of what we experienced, both in what we played and how we played them. And then obviously, we started generating big communities. Esports, 37 million people saw the championship at the Staples Center last year for League of Legends. That's crazy. I remember when Twitch and all these streaming services first came out, and I thought, okay, I get it kinda, but I want to get out there and do something. Well, I was wrong, and communities have become a bigger part of what we do. And through communities, or through esports, we've created these large communities, which then needs a network. And so, what kind of network do we have? We have Twitch. How fantastic is that? Now we can watch from the comfort of our own PC, our own home, people playing the games. If you play Battleborn, I don't know, anybody play Battleborn in here or tried to play Battleborn? Man, I want to kill myself playing Battleborn. Hard game, great game, hard, right? Same thing with, what was the Soul Calibur, right? As a fighting game, I'm not a fighting game guy, but it was a really hard game to play. So if you want to go in there and watch somebody play a game and get some notes as to how to actually get through the game, you go to Twitch. But it also provided a community of people interacting with each other really directly. And so in the old days, you know, I started out playing adventure games. And anybody here remember Al Lowe? Nobody? Oh, poor Al. You remember Al? Al was genius, man. So adventure games, you would put in this, it would be a parser, and you put in, you know, go to the White House, or open the mailbox, or use the pin with the book, and then open the door. And it was a great puzzle-driven experience. And we used to go to Prodigy and places like that to get our hints. Well, Al used to be able to speak to us through his narrative inside the game. Al was genius. And so as I'm playing Leisure Suit Larry, which is one of my favorites, and I'm trying to figure out what I'm supposed to do. And I'm talking to Al. Al, what are you doing, man? What am I supposed to use? What am I supposed to use the pin for? How am I supposed to get into the back alley in order to find whatever I need to get? And I had that direct conversation with Al Lowe. And so through Twitch, now I can really have that conversation. I can literally hang out in the same venue, the same environment as Al Lowe, or you know, are my favorite designers in the world, and ask them, talk to them, get inside their heads. And so, you know, for those of you who know a little about Amazon, you know, we care a lot about customers. And so when we started thinking about building our platform, we wanted to ask developers firsthand what mattered most. And so through Twitch and other experiences and other venues, we started asking, what are the 3 things that matter most to developers? You guys tell me whether these resonate with you or not. But the first thing is speed. Now, we as game developers want to move really quickly, right? We want to innovate. We want to iterate very quickly so that we can actually learn from what's going on. Now, everything on paper sounds great, but when we're actually interacting with it and testing it out, we learn from that experience. And so we want very fast iteration loops. Very important for our game development. And then once we get through the game development process, we want our games as in many people's hands as we can. We want reach. So Twitch and Amazon.com and other venues that allow us to get our games out into as many people's hands as possible is really critical for us. And then the third thing that we heard from developers is that we want users. We want monetization strategies and design tools and analytics capability and a way for us to have a direct relationship with customers so that we can better understand what they want and how they're experiencing our game. And then we iterate from there. And then the fourth thing, we said, okay, look, this is what's important to you now. If you were to say what's going to be important to you in the future, what would it be? And overwhelmingly, people said that they thought that the cloud, both storage and compute in the cloud, was going to be a bigger part of their experience in the future. Not only a bigger part, but many believed that it was going to be critical, if not required, within a 3 to 4 year time frame for people to use the cloud, compute, and storage to get outside the single box. You know, historically, we used to come up with these great design ideas. I can't tell you how many design documents I've written that were like this thick. Brilliant ideas, right? Great ideas. It's gonna be an RPG. It's gonna have action elements. It's gonna first-person shooter. It's gonna have all these mix of mythologies involved. And what we're gonna do is we're gonna change the whole world of games. And then we find that what we can actually do is limited. We have to execute with a limited palette. Well, that's one box. And when we start talking to developers, we start asking how compute and storage could impact their ability to reach and to build better games, they thought, how can I get outside the single box? Well, use storage, compute, the cloud. The whole vertical world, the horizontal world of storage and compute can be at your disposal. And so we built a technology platform for the future. Now, we like to think of our platform as the 4 C's. And the 4 C's are very simply client, cloud, community, and commerce. And all wrapped very tightly around a connective tissue that we like to call support. Support's very important for us. And we've also discovered that making games is hard. Making games to your vision is hard. Making games and multiplayer games is even harder. And so we want to make it easier for you guys as game developers. And so the very first thing that we want to do is help you at the very pre-production phase of your development. And so we built something called Lumberyard. Anybody here heard of Lumberyard? Awesome, great. So Lumberyard is our client. It's our AAA engine that's pre-connected into the cloud and integrated deeply with Twitch. And Kevin's going to tell you a little bit more about the detail about how that all works and give you some walkthrough. But in general, we wanted to create an experience for developers so that when you're there at the very first day of designing and visualizing your game, you can think in terms of how the cloud and how community is going to be a big part of your game experience. And so Lumberyard is our AAA engine. Now, what do I mean by AAA? Well, first of all, performance is really important. Fidelity is really important. So if you have a high fidelity game, you used to have to give up performance because you had that limited palette. Well, we believe through our technology platform, both now and in the future, that that'll no longer be necessary, that you can actually realize all your visualizations and your design at the very beginning. And you can do it with great performance and great fidelity and in a modular way from a development process. Now, what's that mean for modular? Well, we recognize that a lot of game engines were initially built so that you didn't have to worry about all the little small pieces, which is cool, right? It's a good service for us. We used to get off and get our physics engine, and we used to get our animation technology and everything and bring it all together. And then we started using engines that had it all combined into one. But then you got this great, big, huge thing, this monolithic piece of code. And so we thought, how can we make that easier? Almost like using Perforce, where you're checking things in and out. So we started building Lumberyard to be more modular, so that you can impact the parts of the game that are more important for you, so that you can actually customize your experience. And our services and tools can be tailored to your specific needs as a game developer. And you can build games and worlds like this. Now, this is an environment that we created with Lumberyard, and it's not showing great on the screen. So close your eyes for a second and visualize really high fidelity. In fact, if you want, you can come, we'll walk around here in procession and you can see it on the screen. It's a lot better. But they're beautiful worlds with lush environments, with great characters, and you can also build worlds that are very stylized. Now, I was at Disney for a long time, so this kind of speaks to my heart a little bit, but it's very difficult for us as game developers to create worlds that are believable, that are stylized like what you can create in Lumberyard. And this was made with one of our internal developers and very early on, a very short order of time. And you can create very compelling characters. Now, this is Rin. We put Rin together in a pretty short amount of time, a month or so, pretty quick. Really focused on the fidelity and the detail of Rin. And Rin is a character inside the world that you just saw a second ago. And Lumberyard allows you through the tools and services to be able to create fidelity to that level. And the client, in general, on the platform side, is platform agnostic. And so, we get questions a lot about, are you guys trying to make this for the Kindle? And actually, we would love it if someone could find the creativity. If you guys, and we believe you can, could find the tools and services that we provide and use your creativity to interact with the Kindle or the Echo or some other things like Alexa or whatever, that'd be awesome, right? Our goal is to provide you with tools and services to let you guys utilize your creativity on whatever platform you see fit. So that means Lumberyard and all of our services, PC, console, VR, and mobile. And there's a shot of mobile that if you guys are interested in, I'll show you afterwards, and we'll huddle around in a little corner and I'll show you a little video. But we are platform agnostic and want to support any engine that's viable in the marketplace. Oh, and yeah, it's free. And it's not a little free. There's no seat licenses. There's no back-end royalty. Our objective is not to find a way to make money off of your efforts. It's really to provide you with tools and services so you can make better stuff. I was at Activision for a number of years, and we had what we called an independent developer model. And that meant that we wanted the independent developers that came in as a part of our corral of developers, Treyarch, Infinity Ward, and we wanted those guys to be able to utilize what they were best at, make great stuff. We didn't want them to worry about all the undifferentiated muck of infrastructure. We wanted them to work on their great stuff. So we provided any kind of services we could. It's exactly the same thing we're doing here at Amazon. We want to provide you with tools and services so you don't have to worry about the infrastructure side. And so Lumberyard is fully free. 100% fully free. So before I hand you over to Kevin, who's going to share with you some technical information, I just want to reiterate a couple different things. Now, just like those game developers and those game players from 25 years ago, as committed as we are to play and develop our games, we at Amazon are 100% committed to a few things. One, we want you to focus on the more important parts of your game. We want you to focus on ways to help your game succeed, quality, innovation, detail to the design, and not have to worry about the infrastructure, the things that are undifferentiating for you and your product. And at the end of it, we really want to provide end-to-end solutions for developers. Client, cloud, community, and commerce. And I said at the very beginning that I was hoping that you were going to come away with two primary things. One is we are fully committed to you guys as developers. We will find a way to help you with your game development. If it's not in our current roadmap or current plans, we'll find a way to get there if it's important enough to you. And we're fully committed to helping you through your experience. And then the last thing is that we're about community-driven games. You think about what community means for our games now. Think about World of Warcraft, League of Legends, millions of people around the world going in just to interact, to play a game. I don't know if you guys play World of Warcraft, but I was that guy at 4 o'clock in the morning waiting for me to get the last 2 bubbles so I could level up to level 15. And then I'm going to bed, level up. Oh man, I got all this cool stuff. What am I gonna do with this cool stuff? I gotta test it out. So now it's 4:30, 5 o'clock in the morning, and now I've tested all my stuff up. What do I have? I have 2 more bubbles to get to the next level. It's called the compulsion loop. It's compelling for us as game players to be a part of these large communities where we enhance and grow our capabilities. And everything that we are doing is designed to help you build games that do that and build vast, vibrant communities. All along the way, using the unlock of compute and storage of the cloud. Now, I talked a little bit about Twitch. Twitch has reach. I talked about how many people watch the championship of League of Legends. And there are 100 million monthly active users at some point in Twitch, 1.7 million broadcasters and streamers. So we're providing you tools and services to help you reach those broadcasters, which are kind of the middle market, the glue that helps those games drive communities. And Kevin will talk to you a little bit about that. And Amazon.com obviously is a wide-reaching capability for you to connect in and understand better your consumer, also through big data, monetization tools, so you start to see the vision for commerce. And physical goods. I don't know if you guys are familiar with Merch by Amazon, but Merch by Amazon is a really cool feature that allows you to go and design a t-shirt or a physical good along with your software, get it out there, and that bundle is very compelling for customers and creates more of a value proposition. All these tools are things that you will have available to you through Amazon Game Services. And think of a day in the future where you design a piece of a game, and instead of having to be limited to that little bitty palette, you can use the horizontal nature of the cloud in order to expand your vision. You can also go inside your client, your IDE, and you can build a character, and you can hit a button inside that goes directly to a fulfillment center at Amazon, which then 3D prints your image and your character and sends it directly out to either your consumer or your studio. So think in terms of how cool it would have been in the old days of Toy Story to have the toys of Buzz Lightyear all up on the wall, as you could see the progression from the very beginning vision of Buzz Lightyear to the very end. And we will provide those tools for you. And so, enough about all of the more entertaining side of it. Kevin is going to give you more detail on the technical side of it, which is very entertaining.
Which is very entertaining.
Hope you enjoy it. If you have questions, I'm happy to answer in the back of the room. And if you want to see that video, we'll huddle around and take a look at it then. And I want to thank you guys for your time and your patience, and hope you enjoy Kevin's talk. Thank you.
All right. Thanks. Awesome. All right. Thanks, Dan. Can everybody hear me off this mic? Good? All right. So a little bit about me, just very little. I've been on the Lumberyard team for about 2 years. I'm currently in a technical evangelist role, so I get to go and talk to developers like yourself, talking about Lumberyard's product and services. Been in the game engine tech for over 15 years, evaluating engines and middlewares, likely some of what you guys are doing, and then supported the adoption and evaluation of various engine technologies and middleware. So it's really, really fun stuff. We'll get to crack into it just a little bit with some technical demos. I'm going to cover a little bit on the editor. This session's focused, though, on the cloud-connected features. So we're going to talk about GameLift, a managed service that allows you to deploy your multiplayer servers and manage them to a very, very large scale. Cloud Canvas, which brings visual scripting tools and AWS into the Lumberyard Editor, so that as visual scripters or coders, you can work with AWS resources easier. And then if we have time, a little bit about Twitch. So if anyone isn't familiar with a game engine, just a quick primer. This is the Lumberyard Editor. We'll go into this hands-on in a few, but I just want to highlight some of the main reasons why people use game engines and editors, and why Lumberyard specifically offers very good tools for a wide selection of games. The Lumberyard Editor is really the development environment. If you think of the IDE or the Visual Studio for coders, right? This game, Lumberyard Editor itself, is that development environment. It's where you can see your gameplay come to life. The content tools such as 3ds Max and Maya use this as a central point for importing your content into your game. And it's also where you collaborate with your other developers through version control or other means. There's a host of environment tools. The image you see here is a very nice valley that the terrain itself was sculpted in the editor, where you can create what are called height maps that apply to your terrain, so you can make these beautiful, vast regions and valleys and basically any type of terrain while doing it with high performance, like Dan had talked about. You can then paint this terrain with vegetation. You can control how the world animates as time moves on, sunrises, sunsets, and you can control all of the visual elements for that. You want to bring that environment to life with things like particles, smoke, fire. We have a particle editor that allows you to build very complex particle systems and bring them into your game. You can have CPU or GPU particles. GPU are a bit more performant. It can interact with physics. And it can also be paired with characters. Because characters are very important for games too. Character tools such as Geppetto are tools that we've developed to help bring those characters to life inside of Lumberyard. Geppetto allows you to take characters that were exported out of tools like 3ds Max and Maya and load them inside of Lumberyard and then apply overlays to them. So you can physicalize elements of your character and make them more interactive as a player is playing with them. The Ren character here has physicalized hair, parts of her outfit move around as she is animated or as a player controls that character. Tools like Mannequin are general purpose animation systems, and TrackView is a system inside of Lumberyard that lets you choreograph the cutscenes that you might want to build into your game. Switching cameras, animating characters, playing audio, basically all the things that you might want to do in cutscenes. Those elements need to look great, and a material system inside of Lumberyard is the material editor uses a shader-based system to render those materials onto whatever elements are in the game engine. At its core, as you saw in Dan's graphics there, there's not only stylized but also physically based rendering of the materials in the system. So you can go for a realistic view or you can go for a stylistic view. Some games need 2D user interfaces. We have a tool for that so that you can get up and running really quickly inside of the editor and create some initial gameplay. This might be a really interesting thing to look at first inside of Lumberyard as you potentially want to use AWS resources and see the output of that. You can use texts and buttons to interact with your Lumberyard gameplay logic in Cloud Canvas, and then receive information back from, say, S3 or DynamoDB. But the 2D UI tool is a great thing to start playing around with, because it also links directly with the Flowgraph visual scripting tool. The flow graph visual scripting tool lets non-coders interact with a lot of things and build gameplay. And the gameplay can be built with this tool or Lua for scripting or C++. In fact, anything can be done in C++. The entire engine is, the source code is made available to you when you download and install it. So you can do quite a lot with this visual scripting tool. And Cloud Canvas is a feature that we'll talk about and go through in a minute that uses these visual scripting nodes. But the UI editor earlier is also really tightly integrated into the visual scripting tool. But that's your quick primer on game engines. Hopefully you know a little bit about game engines now. But we're going to focus on the cloud-connected features for the rest of the talk and get into the actual actual resources themselves. So the cloud-connected features, the first thing we're going to talk about is GameLift. GameLift is the first managed service that shows up in your AWS console under the new game development section. It's pretty cool when that was finally launched. There's finally the first of hopefully many game development services for people to make massively connected and scaled games. GameLift is a managed service for you to build and deploy multiplayer servers for your players. And hopefully you have many, many players. We can talk in the counts of millions. Have your players connected to these GameLift servers and be there for when they want to connect and enjoy your game. But we'll get into exactly how to do that because scaling multiplayer games is hard. As Dan mentioned, sometimes those games launch and we can't quite connect to them. There's a lot that has to be done. And the GameLift service actually lets you deploy and scale these multiplayer servers in minutes. Now, I'm probably talking to some very, very smart AWS engineers here that know that you can build a system like this yourself. And that's absolutely true. You'd need to design and architect it, build the prototype, maybe build it again or make some fixes into what you've built. But in the end, you have to debug, scale, deploy, launch it, and have 24/7 live ops to support this. And all of that while optimizing for cost. It's easy to throw money at a scaling problem, but it's not usually sustainable. With the GameLift service, it's easy to use, and you can start in minutes. First, you upload a server binary. I'll show you how to do that. We'll configure a fleet. Again, we'll do that. You can scale up, and we'll look at those tools inside of the AWS console. And finally, players connect directly to your server. In fact, they connect directly to the server that it offers a easy, fast, and low latency experience for those players. Not only is it a direct connection, it also is supported in multiple AWS regions. GameLift currently is in the 4 that you can see, Oregon, Virginia, Ireland, Japan. The next 5 will be coming soon, be coming online soon. And then more as we see the players are needing those AWS regions to be lit up for GameLift. As we roll that service out to all the different regions, what is being put there are 2 layers for GameLift. The first is session management. This is an important layer. It's the first experience that a player and a client will connect to. In this example, you can see a player goes to a session management layer and says, I'd like to play a game. The session management layer goes ahead and reserves a spot. The player is then told what EC2 server to connect to, the port and security information, and then the player connects directly to that EC2 instance. At that point, the player and the EC2 server are directly connected. What that means is there's no additional latency from the GameLift service. It facilitates the fleet, and we'll go into the detail on the GameLift fleets of your EC2 servers, but in the end, your player experience is exactly like you would want it to be, with no additional overhead. In addition to players connecting to your servers, there's a lot of operations that need to happen to manage these fleets. We offer the unified web interface, the AWS console, which we'll look at. There's command line tools, and there's a C++ SDK specifically for GameLift that you can download from our site, which you can use in your own applications. Some of the nomenclature and what we'll look at in the console is a build. A build is a server binary and the associated assets of that server. That build is then given to GameLift via the command line interface, typically. When you finally have a binary build in your GameLift account, you can then create and deploy a fleet of servers. A fleet is a collection of EC2 instances, and it can range from one to many. And these are what the players directly connect to. You saw the diagram before of what how a player interacts with GameLift. But this is how a developer connects to the AWS information for their builds in GameLift. A developer creates a build, as you see on the left. That build then creates a fleet which has multiple instances. And think of a fleet as a version of your server. It is that specific version of that binary deployed to those multiple EC2 instances, which can then be scaled up because the binary is not going to change. You just need more of the same type of EC2 servers. They can scale. I'll go into some of these rules when we load up the console. But the AWS console itself for GameLift actually lets you see real-time the health of your fleet and the activity of all of the EC2 instances that it is actually controlling. Because in the end, you could have built this yourself, or instead, with GameLift, you're able to pay as you go with no upfront costs. It's an infrastructure that's already AWS tested. You pay for the on-demand compute and the bandwidth for your EC2 instances, as well as $1.50 for every 1,000 daily active users. In the graph below, let's say I was going to develop this myself, and I set just 300 servers for my players. Well, I don't always need that many. So underneath, you can see multiple regions of GameLift fleets rise and lower based on the regions that they're in North America, et cetera. So the average overall will be lower, and the costs can be, say, 30% savings. In addition, you'll have the AWS guaranteed GameLift managed service. So let's get out of PowerPoint and see if all this works. You can see my screen perfect. All right. So what we're going to do is, with Lumberyard, you want to first select a project you want to work with. So we're going to work with a multiplayer project, which I just set there. I'm going to open up a cheat sheet of notes. Okay, so just making sure the mirroring works. Okay, I'm just stepping you through a quick overview of the multiplayer tutorial that is online for you to do this yourself. So if you don't catch any of these notes, they are all online for you. If we look at a server itself, I've already built this, so we'll do a very quick cooking show. So I'm going to load up the Explorer here, and in one command or in Visual Studio, you can build your server binary. So it's a C++ project, and in the end, it will create this this directory of binaries that are your executable and DLLs and everything else. There's another command to generate what are called the pack files. And the pack files are your game data. And in fact, we can see this final folder is the output of that batch file, which includes that dedicated folder with all of the executables for the server, as well as everything else that's needed. If we want, the next step is to actually test that server. Because there is no difference for that GameLift server running in that Lumberyard server running in GameLift or not. You can run that server locally. In fact, I just did. So if we go ahead, we're going to run the map multiplayer, and there's no errors, and it's starting to do some connectivity in the corner, which you probably can't see, but that's fine. The point is you've tested your server locally. And then in the end, you're able to just, via a command line interface, you're just going to go to AWS GameLift, upload build. You're going to give it a name, a version, and a folder that you want to upload, and it's going to start uploading. And we'll come back to that later. we'll speed through the cooking show style here. So I'm going to log into the AWS console that has a GameLift fleet already running. Okay. So first, when you do finally upload your GameLift binary, it shows up under the builds section of GameLift. We already have one here. It's a multiplayer test build that's been uploaded a while ago. Once you have your binary uploaded, you create the fleet from this binary. Again, it's going to take a snapshot of what you uploaded, and then it can distribute it along those EC2 servers. You can give it a name and a description and a build version. We support a lot of different EC2 instance types. I think it's like 28 or something like that. We recommend going with a C3 large and offer a free tier of 125 hours a month, free to use. So we're gonna leave that there. You give it a path to your executable, launch parameters, and maybe how many processes you want to run on that server, because you can launch multiple processes. There's scaling policies, which I'll show you in a fleet that's up and running. There's port settings. You want to open up a port. Everything's locked down, of course, as it should be, but you open up a port or the ports you need for your game server. There's a protection policy that lets it so that it doesn't kill a server that has players on it, which is useful. And then you just say initialize fleet. Now, we're not going to do that. We're going to skip to the next step, where we go to the fleets. So in the fleets, I have a multiplayer project fleet based on that binary, already alive and up and running. We can see its status. It's active. It has a fleet ID, so you can reference that as an AWS resource. It's using that EC2 instance type. There's 8 instances right now, and 8 of them are active, ready for players, but there's no game sessions and no players. So the important part about GameLift is the ability for you to scale. Let me go back to the scaling tab. We're going to zoom in, say, in the last 8 hours, because I've been playing around with this guy. At the bottom of the scaling tab are your scaling policies that you can totally set up yourself. For example, I have scale down that says if idle instances are greater than equal to 10 for 1 minute, then scale down by 2. But I should scale up if idle instances are less than or equal to 6 for 1 minute, then add 2. You can see those in action, where I was down at 1, I believe, on the number of servers. It went up to 5 because there was actually a desired limit, which is also taken into play, or maximum that's taken into account. But then I bumped it up to 10, and it ticked its way back down to what was needed in auto-scaling rules. I'd never directly modified the active number of servers. I forced the 10, and then it auto-scaled down. So those steps were those are where the auto-scaling tabs come in. Now at this point, we have a fleet and we can connect to it. It would just connect, and you would see that. For time's sake, I'm just going to show you what the game sessions look like, so we don't have to load up something real quick. This test server that I had launched earlier today, it automatically creates a game session. And in that game session, it automatically creates that player ID, because the session management layer goes ahead and tells that specific server that that player is going to connect. So that's what the associated player ID is. Okay. There's more that you can do with GameLift, but we're going to pop back to the slides to overview the rest of them. So you can monitor your fleets. You saw the scaling tab that showed you how many active servers there were, but you can monitor the health of your fleets as a whole. The fleet analytics are automatically generated for the standard things like CPU uptime, but you can also check the statistics on your specific processes and game-specific events that maybe you want to log inside of an aggregated collection of data that you can see on the AWS console. Now that you have a server up and running, hopefully millions of players, now you got to make an update, which could be very, very difficult. So there's a service inside of GameLift called an alias. And an alias allows you to create a name that then points to a fleet ID, which you saw earlier. So I could name production as what my client points to. In this case, in this example, as a developer, I create build A and fleet A. And I tell players with their client to connect to my alias. So that's where we've gone. But now I've created build B, and I've deployed fleet B. You simply rename or point the alias to the new fleet ID. And players that are on fleet A will still play. Again, remember, they're directly connected. Players who then leave that, or new players that come in, will connect to fleet B. And as players leave fleet A, the scaling down rules will trigger in. And as fleet B gets more demand, the scaling up rules will kick in. So your two pools will grow so that the overhead on deploying updates, first of all, there's no pain to players, and second, is cost effective. You can automate this. There's a blog post that we put out there for automating your deployments for GameLift. So in summary, GameLift has so many benefits to anyone who's using or developing games that are session-based multiplayer games. The scaling up and down is very effective for saving costs as well as guaranteeing a good player experience. Tracking the health, it's low latency, the live updates. All of this allows you to make sure that your players have the best experience possible, and you only pay for what you use. Instead of building it yourself, use a GameLift the managed service, and then focus on your game, which is what we want everyone to do. So that's GameLift. The next thing I'd like to show you is Cloud Canvas. And Cloud Canvas, like I mentioned, uses the visual scripting tool, FlowGraph, that you saw a picture of earlier. It exposes nodes inside of this visual scripting tool that let you talk to various services to build cloud-connected features that we'll get into in a minute. But the Cloud Canvas feature also lets you define the AWS resources that you want to use for your game, and using CloudFormation lets you deploy stacks of those that could be production or development, all inside of the editor, because what Cloud Canvas does is it takes away a bit of the scary part of the AWS console. It can be a little scary. And it just keeps people in the developer, or inside of the engine. Features that can be developed like this are features like Cloud Save, leaderboards. You think leaderboard, no big deal, but if there's 30,000 people completing a game every minute, those are transactions, and if you build it yourself, you may not design it right. Cloud connected features like this can be developed with Cloud Canvas. So in order to do that, developers face a lot of problems. They want to iterate on designs, but it takes a lot of time. You also have to have you have to know what services to use. So if I want cloud accessible storage, this one's fairly easy. I probably want to use S3. But when someone first logs into the console, it's a little more confusing. Persistent data in the cloud using AWS, I'm not sure how to get started. Cloud Canvas points you to DynamoDB, which is a great solution, most popular solution with game developers. I need to execute some code that I can guarantee is secure. Well, the solution for that would be Lambda, and Cloud Canvas makes that easy. Then managing identities with games. That's a very big challenge, actually, to go across different platforms, like Dan had mentioned earlier. The service for that's called Amazon Cognito, and it's actually a central point of the Cloud Canvas functionality itself. So Cloud Canvas is the connection between Lumberyard and AWS resources like the ones I've mentioned. You can define those in the resource manager, which I'll show you, and then you can communicate to those resources with the visual scripting tool. But keep in mind, you can also work with those resources using Lua scripting or in C++. The necessity to manage those AWS resources and stand them up and deal with the security is something Cloud Canvas solves for you. So more teams can collaborate and work with AWS resources. So the resource manager lets you define the resources. We'll take a look at a project, deploy those stacks, and then you can remove and add the AWS resources that you want specifically for that stack. And in the end, it's a CloudFormation description. that you can go into and even modify where maybe the tool doesn't let you add every sort of specific detail you would need. Go in and modify the XML. The other thing is that file lives with the project. So in essence, your AWS infrastructure is versioned with the specific version of the project that you're working with, which, let that sink in, it's a big deal because it's always hard to line up the AWS resources that a game communicates to. So you can maintain that description. You can have as many copies as you want. Again, it's just deploying another stack based on that formation definition. And it's all secure, as you would expect. So let's pop out for a quick example on Cloud Canvas. Close that. I'm going to go to the project configurator, and I'm going to go to a sample game. So I'm switching the project here. Let me load up the editor. So what I've done is I've built a game that actually just uses the 2D UI tool like I mentioned earlier. And it lets you connect to AWS using anonymous Cognito and have an identity. In this identity, I can have two different profiles for a player. These are stored in DynamoDB. It's actually configured by an S3 bucket. The game itself looks very simple, but like I had mentioned before, it lets you connect to and work with AWS resources very easily. So, live demos, let's see how it goes. All right, so it's connected to AWS, and I have two profiles here, a demo user and a new user. This demo user, when I select it, it loads up these different DynamoDB database entries. And I staggered them, so it loaded them all individually so people could understand what was going on. If I choose to select like Africa or one of the other entities here, what we would actually get is we can actually battle for the specific, the resolution change actually caused a problem, it looks like, on actually doing a battle. But it doesn't change the fact that it's loaded the DynamoDB. And the way it's done that is in the visual scripting tool, flow graph here. If I look at the configuration, there's a lot in here, but you get to work with AWS resources like S3 by simply triggering via a green arrow, which is just an event from any sort of game trigger. I think this is game configuration start. I have my friendly name for the bucket, which is defined in the resource manager, which we'll look at. So it's not directly referencing a specific bucket, but then it grabs a file. When I did the character select, I went in and actually read if I had a character one which existed from a DynamoDB get item. And if it did exist, I was going to go and read that display name. As you can see, you just use these nodes and you pull them into your game. And how does that work? So first, the Lumberyard Editor knows about AWS from the beginning as you add a profile with your credentials. And you can give different team members different credentials so that they can have one that maybe artists who just need to play the game. They would have the right credentials. But when you go into the Cloud Canvas Resource Manager, this is where it gets interesting. So I have created a definition called My Resource Group. And it shows the two DynamoDB tables, an S3 bucket, as well as a Cognito pool. And it's actually defined through CloudFormation like you would probably want. You can then deploy those stacks. If we look at the actual deployments inside of the project stack here. So we have a dev deployment and a production deployment. And in fact, you can select which deployment you want to be using. So if you go into the AWS menu again, you can select a deployment, and we can switch it to the dev deployment. It's going and now mapping those friendly names for DynamoDB and such to the DynamoDB tables that it actually needs to be working with. And once that's all mapped, see if it's done, we'll load the game again. And I have a different set of users because I'm a different Cognito pool for this one. So that's how you can work with Cloud Canvas. And in the Resource Manager, just to make sure, because I'll make a point of it, in a minute. In this resource group, this is where you can directly add new resources. That's S3, DynamoDB, Cognito, SNS, and SQS, all outside of the AWS console. Okay. As we wrap up, let me pop back. So those AWS resources are useful in the cloud, in Cloud Canvas via FlowGraph, but you can use the AWS C++ SDK, which actually was developed because of Lumberyard. We made sure that there was C++ access directly. You can create in C++ instances and work with AWS resources directly. In fact, at the Game Developer Conference this year, we talked about that AWS C++ SDK, and we have the source code available on GitHub. So just last, real quick, because I'm excited personally about Twitch. Twitch changes what kind of games we can make as game developers. One of my favorite graphics here is you have a game inside of Lumberyard, or you have your game that your players are playing. You then have what's called a broadcaster in the audience. This creates an absolutely new dynamic. And this isn't a talk focused on it, but we've taken that approach. For example, one of our games that we've unboxed and announced recently called Breakaway uses these kind of features. And if you have a second, you should look into that. But the Twitch integrations that we offer include chat play, which lets you, inside of FlowGraph, which you saw, listen for commands inside of a Twitch chat channel and then execute gameplay. So Twitch Plays Pokemon is an example of that, where people have done this themselves. That's great. But we want that directly inside of the editor and in your game. Twitch Join-In lets the broadcaster challenge one of their viewers and send them a link in Twitch to join their game and say, oh, if you think you could do that better, then OK, join the game and let's actually see what happens. All very exciting ways to change how gameplay will exist over the next few years. I'm excited, obviously. So we're at the end. Where do you get started? Google, obviously, and figure out where to get started. AWS, Amazon.com/Lumberyard. You can download it, again, completely free. Dan wasn't saying anything that wasn't true. It's all free. The source code is there and made available to you. No subscription fees, nothing like that. The installer you download, super small. It then downloads all of the packages to get you up and running. And we even have a setup assistant that makes sure that your development environment is set up for you. If you're just an artist, there's less overhead. But if you're going to actually compile your own server, there's some more dependencies, and it takes care of that for you to get you up and running. But thanks again for coming to this session, and hope you have a good conference.